Hello and welcome to a chapter on administering a secure network. Excuse me. Uh, let's get started. So on this chapter, we're going to talk about TCP/IP protocols and how data gets encapsulated, and we'll discuss how to really connect. How to secure a TCP/IP network in general. We'll talk about the network administration principles that can be applied. And we're going to define new types of network applications and how they can be secured as well. All right, so when we're talking about protocols are like standards on how you are supposed to communicate. So there is a standard on how we, for example, to a protocol on how to send a letter in the mail. You have to be able to write the letter, put it in the envelope. The envelope has a certain width and height. You have to place the source um, source address in a specific location, and so is the destination address, and it has to be in a logical order: name, street address, then city and state and zip code. Right? If you write the zip code all over the place, it won't be. It's going to be a problem, and your letter will never get to the destination. Right? Same thing with data communications. The computer will has there are protocols on how to actually repackage the data. We call that encapsulating the data. Data starts from the application layer, and there are rules, protocols on how to encapsulate the data, where to stamp the labels, and finally how to deliver them to the final destination. Um, these rules we follow using the OSI models. There are certain steps as your data gets encapsulated before till they reach the physical layer. Routers and switches. Routers are like post offices. They help us move the letter from one place to the other. Routers look at IP addresses to find where the location of your network is. Just like post offices look at zip codes to find where your location is. So routers are like post offices. IP addresses are analogous to zip codes. And then the switch, when you finally get your data to the final destination, then your switch is like your mailman in your city, in your area, in your zip code, and will find your home number, the number on your home, right? The house number or the building number. That's like the MAC address in your zip code. So the switch finds exactly where that house is. And once the data gets to that number, the MAC address, that's at the data link layer, then the person in the house, there's probably many different people living in that same building, according to the name on that letter, will be able to find who that letter is for. In the data communications on the computer, you may be running several different applications. And these applications may be, SMTP, sending an email, and or doing HTTP or telnetting or whatever that you're trying to reach to the other destination. Port numbers will identify what type of applications. So, to generalize, routers are like post offices. IP addresses are like zip codes. The switch is like the mail person in your area that's trying to find that knows where all the house numbers in a specific zip codes. Those house numbers are like the MAC addresses. The port numbers are like the person in the house, right? So you can find exactly what it is. All right, the IP protocol is the one that packages the data, and it takes the segments from the transport layer from TCP and puts in the most important thing that the internet protocol does is it places the IP addresses, the zip codes on the packet. TCP, the transmission control protocol, he's the one that's going to make sure that the package reaches the destination. This is just like doing registered mail. Registered mail makes sure that the person has received the package, and if they don't, they'll let you know, and so they can actually resend it, right? So that's why we call them TCP/IP. Most TCP communication is when it goes outside your LAN. And here's the OSI model that we were talking about. This is the old TCP/IP model, originally how it was created. The application layer. Actually, these two, so you had application, host to host, which is transport, internet, and this is called internet access, that one layer on the bottom. That's the TCP/IP model. This is the OSI model that was, they came up with it in the, I think, late 70s, early 80s. This is original, TCP/IP model, how data was supposed to be encapsulated. You start with the applications, you pass it on to the transport layer, then you pass it on to the internet, then you pass it out to the network access. For example, if you're going to send an email, you use SMTP protocol to create your email. You pass it on to the transport layer. That's where TCP is. He puts in the port numbers, right? He puts in the person's name. Then you pass that on to the internet layer. That's where the IP protocol is. He puts in the IP addresses. That's where you put the zip codes. And here at the network access layer, that's where you put the MAC addresses, the house number. And then it goes on to the physical layer, onto the wire. ICMP protocol. ICMP protocol, the Internet Control Messaging Protocol, is used really to, it's like a manager that oversees the internet. Please write that down, by the way, because we really don't discuss ICMP a lot. So that's one note I want you to write down. Originally, when TCP/IP was created, it did not have any control messages. So for example, if you send your package and your packet got lost on the way, nobody's going to let you know that it got lost. You don't even know if it got reached the destination or not. So that was a problem. So and the Internet Controlled Messaging Protocol now is active on almost all routers. Not almost, it's active on almost routers. For example, if you ping a device somewhere, what you're doing, ICMP creates an echo request packet. That's what ping is. Sends it out to the destination, and if let's say, remember when we discussed this in a networking course for those who were with me, every time a packet leaves the sender, there is a number that's stamped on the packet called the TTL number, the time to live. And that number starts to decrement every time you go through a hop, a router. So if you kept going from one router to the other and you never reached your destination, so the router, if there's a router that receives a packet that the TTL number reaches 0, then it's going to ask the ICMP protocol that's running on that router. It's going to create an echo reply telling you that your packet has died. So you get the timed out. So if you ping somebody and you get timed out, that's an ICMP protocol running on some device somewhere else, telling you that your packet got lost, or the TTL number died, which means we could not find the destination. It could be for any reason. Now, if you want to find exactly where your packet TTL number died, or there's no connection, of course, you use traceroute or tracert if you're doing it from Windows. All right, so here are the different codes that ICMP allows you to do. So it's not only echo request and echo reply, but it could do many others as well. It's really to manage the network and to let you know what's going on, if there's a link broken, if there's a network unreachable, if there's a host unreachable, and so on. All right, so I know we probably talked about some of these, but here are some attacks that can use the ICMP protocol. Network discovery. For example, I can go out and trying to find who my neighbors are, what IP addresses, what protocols they are running, and so on, for reconnaissance. Like we discussed earlier, one of the first things attackers do is trying to find out what ports are open, for example. Are you connected to the internet? Why would I want to spend my time attacking a specific device if it's not even connected, right? So you can use that to do network discovery. You could do Smurf denial of service attack. You can find out who your neighbors are, what their IP addresses are, and pretend to be them and start attacking a specific server, right? That's a Smurf denial of service attack. ICMP redirect attack. You can actually redirect instead of you coming to a DHCP server, I can pretend to be a DHCP server. You'll be redirected to me. Or you could do that with an access point too. Ping of death. You can, if somebody pings me, I have to reply. By default, you are told if you receive an echo request, you have to reply to it if you are up and running, right? Active. But if I keep pinging you, you keep responding back. So if I create an infinite loop that keep pinging a destination device and you keep replying, that's like a ping of death. That's what they call the ping of death, which means you won't be able to communicate with anyone because you're constantly replying to that ping. All right, so please write these 4 points down. These are the different types of attacks that can be used by ICMP. The Simple Network Management Protocol, SNMP. SNMP is designed to manage the network. So what you do with SNMP is please write that down too also, by the way. Just you don't have to on the first two, but you want to say that it allows administrators to remotely monitor, manage, and configure network devices. And it functions by exchanging management information between network devices. And each SNMP managed device has an agent or a service. Now, I want you to write these bottom 3 points down for the SNMP. SNMP, what it does is like you run it on one computer. It's really a protocol. Vendors create a software according to that SNMP protocol, and you put it on a computer. It's going to be called SNMP server, and he sends out like little agents to all the devices on the network to gather information about, those agents go to specific hosts, tell me how often do you connect, what's your IP address, what's your throughput, how busy you are, and you bring all that information back to the server, and then the server gathers that information and displays it in a graphical representation, letting you know how traffic is, if there's any type of network, if there's something disconnected. So by looking at the traffic, you can reshape the traffic, redesign your network, have better security, maybe recreate VLANs and so on. That's the whole idea behind the SNMP, is to give you more information about how the network is. In fact, you can actually, by looking at it, you can redesign the whole network from scratch to be better scalable, for better performance, better security, and so on. And definitely what you want to do is you want to use version 3 because all the agents sending out information back and forth between the host and the server, all that data is encrypted. SNMP version 3 is the one that you want to use. Okay. The domain naming system or service is the DNS is used to, well, here's a couple of notes I want you to write down for those that don't know. The DHCP server, I want you to write this down. The DHCP, the Dynamic Host Configuration Protocol, is the server that gives you the source IP address, like your source zip code, right? To stamp on the packet. The DNS, the domain naming services server, is the one that gives you the destination IP address to stamp on your packet. This is like getting your destination zip code. Now we write www.yahoo.com. That's because we don't know what the destination IP address is. Your computer is going to go out to a DNS server, the .com server, look for yahoo.com, Yahoo in there, and look for that record, and it will give you the destination IP address. That's what the DNS server is for. Now, instead of keep going back and forth every time you want to go to yahoo.com, your computer actually caches in all that stuff. Or you may have a proxy server. Remember we discussed that on the last lecture, if I'm not mistaken, that will cache in all that information for you to speed things up, right? But remember, somebody can go into the DNS server and imagine you wanted to go to yahoo.com. Somebody comes in and puts in a different IP address for Yahoo. So when you go to yahoo.com, you'll be given a different IP, the wrong IP address, and that IP address may be redirecting you to a different server that looks like Yahoo, and they'll be able to gather all the information once you get into that bogus server. So you got to make sure that the DNS server is well protected. Okay, so File Transfer Protocol, FTP. This is for uploading and downloading files to servers across the internet, not necessarily peer-to-peer, not directly like the cont'd protocol for file sharing. We're talking about you can go to a website and upload and download files. But the problem with FTP is it uses it's all in clear text. So whatever you're uploading and downloading can be viewed by any protocol analyzers, or sometimes we call those protocol analyzers sniffers. That sniffs the actual data that's being transferred. So you want to use Secure Transfer Protocol, or FTPS, so that all the data is encrypted while in transit, right? So use FTPS. Most of the time nowadays anyway, most of the downloading and uploading is using HTTPS. So if you're pretty much secured. Secured copy does the same thing as FTPS. IPv6. All the way up to the early 1990s, and when we got NAT, we were running out of IP address. I mean, in the early 1990s, we realized that we are not going to have enough IP addresses available for the fast-growing internet. I mean, I remember in 1995, AOL had like 30 million users in 1 year. That's how fast we were growing. So they got together in the early 1990s and they said, we want to work on expanding the number of IP addresses available, because that's the top, because we realized that we are growing the internet extremely fast. So there was a group that were working on IP version 5 just to expand the number of IP addresses available. Later on, they said, you know what, let's solve all the problems that IPv4 had. So such as the broadcasting, the use of NAT, IPv4 didn't have any security. You have to put IP security separately. The labels that were placed on IPv6 was not that, it was too many labels on the packets. And there are many other, having use of NAT was a problem as well. So there was another group set aside, started working on improving all the other features that IPv4 had, or just eliminating them. In 1998, the IPv5 committee and IPv6 got together and they ratified IPv6. So IPv6 gave us a 120-bit IP address. So right now we have unlimited number of IP addresses available. So for the foreseeable futures, we most likely will never ever run out of IP addresses, not on Earth. Devices can have multiple IP addresses. Users now can have get on the internet without having to worry about data being encrypted. In fact, here's what I want you to write down about IPv6. Note number one, it's a 120-bit IP address. Okay, theoretically, it's unlimited number of IP addresses available. Number two, no subnetting is required because there is a space in the IP address that's reserved for subnets. Number two, no broadcasting is necessary, only multicast address. We'll discuss that some other time when we get into our networking class. No NAT is needed, the network address translation that we discussed in the last lecture. That creates a lot of delay. Now users can have the public or the global address, and they can get in and out of the network without having to wait to be translated. Number 5 point is security is part of IPv6. IPsec, the IP security is part. So all your data is set up is secured. Don't have to worry about security. Um, less labels are stamped on the packet so that the routers can move the packets much quicker. Better for quality of service. You can decide on who can go faster, right? All right, that's enough. Enough points for IPv6. Here, see, even though the address is long, you got less labels. This is IPv4. Look how many labels are on the packet. A lot. This is a lot less packets, right? You got the source IP address, the destination IP address, and here is the traffic class for quality of service to set priorities to the packets. Okay. Some network administration principles that you should follow, some technical principles, that you should really go with. Device security, network management, and port security. That's very important. Configuring a firewall to conform with the procedural rules. Device security. Like I know we discussed that before, you got to make sure your devices are well secured physically and logically. Implement flood guards to make sure that there's no denial of service attacks on your router, especially if your router is set to, it's at the vanguard, is the one that sits in front of your whole network. Analyze all device logs. If you have a syslog server that keeps track of all who is coming in and out of the network, right? What else do you need? So there's your typical router, and it's typically facing the outside world, right? So you got to harden this, probably put a firewall, VPN just to protect it, especially if your router is doing more services than just routing, such as DHCP, and is doing many other services for the internal network. You want to protect it because if it's facing the outside world, it might easily get attacked. The sync flood attack is if you when two TCP devices endpoints want to communicate with each other, the sender always sends a synchronous control signal to the receiver, and then the receiver has to send back an acknowledgement, and you send back acknowledging that acknowledgement. That's a three-way handshaking, and that's why we call TCP is a connection-oriented protocol. Now imagine somebody sends you a sync signal, you respond back, and you ignore that acknowledgement. You just keep sending them a sync signal, and they keep acknowledging you back. So that's what the sync flood attack. Just keep sending them a sync signal. It's just like somebody calling you just to keep your phone off the hook. Flood guards is to protect against just denial of service attacks. How many unanswered service requests can you control? So usually you can chop that off very easily. Firewalls, IDSs, and IPSs usually take care of the flood guards. Log analysis is you got to keep track of all the events that occur on your network and also on your device, on your hosts, on your workstation as well. All right. NIDS, NIBs, DNS, all of these have logs, right? The firewall has its own log, application log, antivirus program log, the application logs, you name it, right? Here's a typical firewall log, for example, telling you the IP address, the destination, the serial port, and they even have the time, everything. Okay, firewalls log items that can be examined, the IP address, the probes, the source routed, suspicious and unsuccessful logins, all of that. The only problem I'm telling you is really what comes with log, nobody really bothers because there's so much information daily, constantly happening. Um, Typically, nobody really looks at it unless something goes wrong, and that's unfortunate. But you need them just in case you want to find out. It's painstaking, to glean over every single entry in the logbook to find out where the problem might have occurred. Probably have to do that. A lot of times we connect the IDS, like I told you earlier, the IDS is typically connected to the firewall and so on. So this way, looking at the logbook, you can have a pretty good picture and you can actually exactly find out what happened, when it happened, and what type of attack, and you can actually protect against it for later on. All right, when it comes to the design management, you want to do a network separation. Growing network may, need reconfiguration, but you want to separate the network. So that's why we create VLANs, right? The human resources should be separated from the engineering department, and the engineering department should be separated from the sales department, and so on, right? Loop protection. Switches typically, when you connect two switches together with a link, we call that a trunk. That's fine, but the problem is what happens if that trunk fails? Then we got a problem. So what we want to do is we want to put another redundant link in there. And if you put another redundant link in there, by default, the way the switches operate, you're going to have a loop. That means frames is going to go back and forth into the switch, and the switch will be, or broadcast storm sometimes it occurs. And what happens is the system fail. The switches won't be able to service anyone if it goes into a loop because of that redundant link. So what you want to do is you want to run SDP. This the spanning tree protocol. Please write that down. The spanning tree protocol prevents frame looping at layer 2 and prevents broadcast storms at layer 2. And also it allows you to have redundant links between switches. Without SDP having redundant links, you're going to have broadcast storms and you're going to have frame looping. No good. All right. The loop protections using the SDP, it's under the 802.1d. That's the spanning tree protocol, right? A virtual LAN, we discussed that. Virtual LAN is like a virtual switch. You can break up the network because a switch is its own LAN, right? So if I take a switch with 24 ports, I can make it into two switches, virtually, one with each 12 ports each, or maybe three of them. One with 6 ports, one with 6 ports, and another one with 12, even though one on the same physical switch, right? That's what a virtual LAN is. Port security. Please write these down because on the switch itself, you can turn off the ports, not required on the network. For example, you can, and we will do this in one of our Cisco classes, we'll be able to set security on the port so that only one MAC address can go through. If there's an intruder, we're going to shut down the interface and send it to the logbook to let you know that something is wrong, and you have to physically go in and shut down the interface and re-enable it and find out who the intruder is. So all that's very, very important, and that prevents a lot of problems such as DNS, DHCP, hijacking, session flood guards, somebody pretending to be a root bridge, which we'll discuss in a different class. So port security is extremely important. Never ever leave ports open and not used. If they are not used, logically close them so no one can connect to them. We'll learn all of that in a different class, of course. MAC filtering, that's what we're going to be doing, right? I told you you can do MAC filtering. In other words, every port will be assigned to a specific MAC address or a group of MAC addresses if you want. And if an intruder comes in, somebody with a different MAC address, you can ask the port to block that frame from coming in, or the best thing to do is to really shut down the interface completely, because it could be, um, some sort of a denial of service attack. Somebody who's trying to attack the MAC address stable to flood it with, poisoning it, flooding it with bad MAC addresses or whatever, right? So port security is important. All right. Well, and you can actually, usually what we're going to be doing is we're going to make it sticky. Those MAC addresses, when we learn the MAC addresses and who is going to be, what MAC addresses are assigned to which port, we usually let the switch learn them. And when the switch learns them, it makes it static. You can actually yourself make it statically if you want. Again, this will be discussed in our Cisco classes in details when we do this. The IEEE 802.1x protocol. Okay, again, I want you to write these 3 points for the 802.1x. I think that's very important because we also see this. This is also implemented with wireless network. 802.1x the way it works is when packets come in to the port on the switch, the port will block all the data from coming in. It's only going to send the request for authentication to go through to a server. So the data, let's say you're setting up, you have a TACX or a Radius server and authentication servers. So when data comes in, it goes to the authentication servers. Like let's say the Radius servers will look up your username and password, authenticates you. The port will still be blocking data. They will not allow you to go through no matter what until the Radius server tells the switch, okay, he's authenticated, open the port for them. Otherwise, you will not go through. You'll be blocked. So that's what the 802.1x is. It provides the highest degree of port security. It's port-based authentication and blocks all traffic on a port-by-port basis until the client is authenticated, right? So that's that. Virtualization. Nowadays, instead of the good thing about virtualization is number one, here's a couple of points I want you to know about virtualization. You have one device, one computer that is the host to the virtual environment. Let's say it's Windows 10. It's going, number two, it is going to have a hypervisor software, a layer. The hypervisor layer is the one that connects the virtual environment with the host operating system. So VirtualBox, for example, has a hypervisor that connects between Windows 10 and all the virtual environment that you have. In the VirtualBox, you can have Windows Server, a Unix machine in there, another maybe iOS operating system, Linux, whatever. So you don't have to have, the advantages of that is you don't have to have a separate appliance for each of those servers. They all could be running on one machine in the virtual environment. That's one advantage. Number two, also I want you to write down that if something goes wrong with any of these devices, one of these servers in the virtual environments, you just close it. You treat it like an app. No problem whatsoever. It's good for testing too. And so you have one machine and you can service everybody outside remotely. It's used for cloud computing. So you can have, all of these devices running on one machine and you can access them remotely, right? So you save money on the hardware and it's much easier environment all in one place. And for problems, it's no problems whatsoever. I mean, if you run into any problem with any of the applications running in the virtual environment, you just close it. The only thing is you got to make sure that the host is stable, has lots of memory, big hard drive, and does not, it's rugged, it's tough, sturdy. It's not going to fail on you. All right. So try to get some of these points that I know I wasn't specific in the virtualization, but trying to get as many points as you can. All right. Moving on. That's the virtualized environment. So to secure the virtualization, you got to do basic protections, restrict changes, auditing, compliance, customizations, and reporting as well. All right. IP telephony. This is not as much done nowadays, especially with the cellular connections, but most organizations now already have upgraded into IPv, voice over IP, so there's not much really to do there. But IP telephony was big in the early 2000s. I mean, when everybody was really migrating from the plain old telephone systems to IPv4, and there was a big upgrade, big push. Nowadays, it's not as much. But with IP telephony, a couple of things you need to know. I want you to write this down. Number one, you need your devices, your switches, and your routers to have the feature of quality of service QoS, which means they have to be able to set priorities to traffic, who can go first and if there's any traffic. Number two, all IP connections should be on a separate VLAN so they can move much quicker. What else do you need to know about IP telephony? There's the gateways but we'll get to that some other class. I mean, there's really nobody really needs to connect them. It's mostly done at the service provider. But you can, by the way, in a building, have your switches communicate. You can create your own IP telephony within your own organization as long as you don't have to communicate to the outside world. You can use your private IP addresses to connect. Oh, one more point I want you to write down about IP telephony. The switches should be able to have the features power over Ethernet, PoE, right? That means your phone will get the power from the switch over an Ethernet connection. Okay, that's all you need to know for that. Cloud computing. Cloud computing, there are many different types of cloud computing you can use. Well, first of all, what is cloud computing? Cloud computing means that your services that you're trying to do are no longer on the local or on the server in the LAN. So you'll go out to somewhere over on the internet using someone else's servers and even your storage. For example, Dropbox, the OneDrive, that's a storage on the cloud. If you wanted to use Microsoft Word, the Internet Microsoft Word, that's in the cloud. You may pay a little fee for it. You may now have a server, a network, you name it, over the Internet. And you don't need any of the devices. We talked about last week, on the last lecture, that you can actually have security, setting up security remotely. They can go in, you just connect to them, to your third party, whoever your service provider is. They can go send information to your device, look at it, and make sure it's well secured. And they'll download and install all the software that is needed to protect you in terms of firewalls, antiviruses or antivirus programs, and so on. So the three services, there are more services, but I want you to write these models down. The three service models of cloud computer. It can be a software, an application as a service, that's SaaS. It could be a platform, like an operating system. You can actually get operating systems right off the cloud, or it could be an infrastructure, everything from DNS to HPC, a whole network. And that's it for this chapter. All right, I think it was okay. We'll get into more details about the networking and all of that in our Cisco classes. All right, until we meet again, good luck.